For years, we've stared at the stars, wondering if we were alone. Every photograph, every signal, every flicker of light was a question sent into the dark. Is someone else out there? And for decades, that question remained unanswered. But then, in the silence of space, the James Webb Space Telescope saw something that would change everything. It started with a faint shadow, a tiny dip in the light of a distant star, more than 120 light-years away. To most telescopes, it was nothing, just another blip in a sky filled with noise. But to the Webb, it was a message, because that dip wasn't random. It was the fingerprint of a planet orbiting a small, cool star, one that looked almost like home. They named it JSX 39b. At first, it seemed ordinary, roughly the size of Earth, orbiting its star in what scientists call the habitable zone, the region where liquid water could exist. But what Webb found next would push the boundaries of everything we thought we knew about life beyond Earth. When JSX 39b passed in front of its star, Webb's infrared sensors captured light filtering through the planet's atmosphere. By analyzing that light, breaking it down into wavelengths, scientists could read the chemical composition of its skies, and what they found stunned them all. The data revealed strong traces of methane, carbon dioxide, nitrogen, and water vapor, gases that together form a pattern we've only ever seen on one planet before, ours. But it wasn't just that. There was something else, a spectral signature unlike anything ever recorded, a compound that shouldn't exist without life. Scientists call it dimethyl sulfide, or DMS, a molecule produced almost exclusively by living organisms on Earth, primarily by marine plankton. It's the smell of the sea, the chemical breath of life itself. At first, no one wanted to believe it. Webb's data had to be rechecked, cross-analyzed, verified. But every time they ran the numbers, the same result appeared: DMS. That's when the question stopped being if there could be life and became how much. Using atmospheric modeling and biosignature probabilities, the team calculated that JSX 39b had a 99.7% probability of biological activity in its atmosphere. Not just potential habitability, but actual signs of life. For the first time in history, humanity had evidence that another living world might exist. News spread like wildfire. Every major agency, NASA, ESA, JXA, confirmed the findings. Webb's instruments, designed to peer billions of years into the past, had instead revealed something profoundly present: a living planet. But what made JSX 39b even more fascinating wasn't just that it had life, it was how it survived. The planet orbits a red dwarf star, smaller and cooler than our sun. Its year lasts just 19 Earth days. From its surface, the star would appear as a dim, blood-red sun, casting long shadows over alien oceans. Scientists estimated that JSX 39b's atmosphere was thicker than Earth's, a dense shield that protected it from the star's intense flares. Beneath those crimson skies, temperatures could hover just above freezing, with thick clouds and slow rolling winds. The data suggested something else too: a strange pattern in the reflected light, a shimmer consistent with liquid water on the surface. Not ice, not vapor, water. And where there's water, there's the possibility of oceans, vast alien seas stretching across the surface of a planet that no human eye will ever see directly. If that's true, then somewhere on JSX 39b, under its red twilight, waves could be crashing against rocky shores. Winds could be moving across a living world, a planet breathing, changing, evolving. It's a thought so overwhelming that even the scientists who worked on Webb's data paused when they saw the results. One of them, Dr. Eliza Moraine, said, "We used to look for another Earth, but I think we just found another home." Of course, skepticism followed. Some argued that DMS could be created through unknown geological processes. Others said the 99.7% probability was statistical optimism, not proof. But the Webb team didn't stop there. They kept observing, week after week, month after month. Every transit, every time JSX 39b passed in front of its star, brought more data, and the signal only grew stronger. Then came the second surprise. Webb detected periodic flashes of green auroras on the planet's night side, caused by charged particles interacting with the atmosphere. That meant it had a magnetic field, a protective shield, like Earth's, capable of deflecting solar radiation. That discovery changed everything again, because with a magnetic field, a stable atmosphere, and the presence of liquid water, JSX 39b wasn't just alive, it was stable. It had existed this way for millions, maybe billions of years. In other words, this wasn't a temporary chemical anomaly. It was a world in balance. As more data came in, Webb's instruments picked up subtle seasonal changes, shifts in methane levels that followed a repeating yearly pattern. On Earth, those shifts are caused by life, plants, microbes, and oceans breathing in rhythm with the planet's climate. The same rhythm was happening there. It was like listening to a heartbeat echo across light years. Humanity had found something extraordinary, a reflection of itself in the vast dark.